This video, we're going to talk about trig substitutions. You should only consider doing trig substitutions whenever you have a squared plus or minus x squared to any power, including 1. That is, there is no power. Or x squared minus a squared to a power, including no power. Just remember that, and if you have x squared minus 3, that this is or can be realized as x squared minus the square root of 3 squared. So don't say, oh, that's not in the form of x squared minus a squared. That's not true. Again, doesn't matter whether you have a square root sign over the a squared plus or minus x squared or the x squared minus a squared. You can have it to the third power. It doesn't matter. These are the only situations where you should even consider trig substitutions. Now, I'm not saying you can only have this. You can have other pieces, like, I don't know, if you have x cubed over a squared plus x squared. Maybe this would be, I would use trig substitution for this one. Why? Because it has this. Or maybe it had a squared minus x squared. So if one of their factors is one of these two or this one, you should consider trig substitution. Trig substitution isn't easy, so I would try to get out of using trig substitution. Never formally tried it, but I assume you can use trig substitution here. But why? The integral of x squared is x cubed over 3 minus the integral of 4 is 4x plus c. Before I can even draw the triangle to do trig substitution, I wrote down the answer. So you really want to try to get out of using trig substitution. But sometimes you can, and that's what this video is all about, when you can't get out of using it. Suppose you have the integral of dx over x squared plus 9. Now you might remember that this is an arctan integral. Fine, but in case you don't remember, when it comes to x squared plus 9, it's understood to be plus x squared. So this piece has a plus in front of it, and so does that. That means the whole thing goes on the hypotenuse under a square root sign. Even if this was to the 5th power, it's going to go there under the square root sign. One of the sides gets the square root of the x squared, and another side gets the square root of 3 squared. And we call the angle u. Now, we want to get dx, and it's really good if you know what x equals, because then you can get dx easily. Well, if you notice, the tangent of u is equal to x over 3. I can put the 3 over there. Well, this tells me 3 secant squared u du is dx. Okay, so I have my dx. Now I want to get x squared plus 9. And again, maybe, I'm not going to keep the 5th power, but maybe to the 5th power. I'll worry about the power when it comes to it. Well, I noticed that the secant of u is this, square root of x squared minus plus 9 over 3. The over 3 I'll put here. Now remember, this is really x squared plus 9 to the half power. If I really wanted the fifth power, I'd raise everything to the 10th power, because half times 10 is 5. But I only want to the first power. That means I'm going to square both sides. I'm going to square both sides. In fact, if you square both sides, you get 9 secant square u is x squared plus 9. And that's all I needed, x squared plus 9. Okay, so I have both pieces. Dx is no random guessing or no trying to remember. Just look, read it off. That's x, sorry, that's dx. And x squared plus 9, that's 9 secant squared u. Well, secant squared u canceled out. 3 over 9 I can pull out in front as a third. So all that survived was du. And the integral of du is u. Now, this here says that tangent of u is x over 3. Now, I can switch those two arguments anytime I want. Not if there were a 7 in front. That is, I cannot switch the u and the x now because of that 3. That's why I divided by 3. So, and when you switch them, you have to say inverse. The tan inverse of x over 3 is u. So this answer was 1/3 u, which is 1/3 the tan inverse of x over 3 plus c, using trig substitution. If you have the integral of 25 minus x squared square root over x dx. Now first I just want to make a little comment. Oops. If you didn't have the square root, you should just do the division. This will be 25 over x minus x dx. That's the integral of the first function dx minus the integral of the second dx. And this 25 can come out in front. So it's just, this integral is just 1 over x dx, which is ln of x minus x squared over 2. No trig substitution, just division. Okay, but the radical kind of throws this off. So when you look at 25 minus x squared, the 25 is plus. The square root of that goes on the hypotenuse. One side gets what's squared, which is x. The other side gets everything under the radical. You learn that, life becomes easier. Okay, like before, I like to get something that says x equals or 5x equals. Well, if I take the sine of u, I get x over 5. Ooh, I can find a differential right away. Then now I know what dx equals. Okay, I have dx. And I have what x equals. So now I just need to find out what the square root of 25 minus x squared equals. Well, if you look at the cosine of u, it's the adjacent 25 minus x squared divided by the hypotenuse. Well, I'll put the hypotenuse there. Oh, so you mean now I know how to write this using u. So I have it all. The square root is 5 cosine of u times du, which is, times dx, which is 5 cosine u du divided by x, which is 5 sine u. I'm going to make sure I have everything right. Sure looks right to me. Okay, so those cancel out. I can bring this 5 in front. I have 5, the integral of cosine squared u du over the sine of u. So what I would do here is I'd call cosine squared u 1 minus sine squared u du, all over sine of u. And then we get 1 over sine of u, which is cosecant u minus this fraction, which is just sine of u du. So this is 5 times the integral of cosecant of u is negative ln of cosecant u minus cotangent u minus the integral of sine of u is negative cosine of u plus a c. Wanted to check one little detail on my last line. This minus sign shouldn't be there. Okay, so now we just want to do one last step. Let me just write down this triangle a little bit lower. This triangle right here. We have u 25 minus x squared, x and 5. Okay, so we need to substitute back two x's. So it's ln of the cosecant of u. But that's the reciprocal of sine. So it's going to be 5 over x. 5 over x minus the cotangent of u, which is this over x. 25 minus x squared over x plus the cosine of u, which is this over 5. The square root of 25 minus x squared over 5 plus c. And the one change I would make is, since these denominators are the same, I'll just say it's ln of 5 minus the square root piece all over x plus the rest. Possibly, if you look in, say, your solution manual, they'll say that the answer is ln of 5 minus this minus ln of x. Think about why that's true. It's a property of logs. Okay, so either one is fine, this last one or the one above. Now, suppose you have the integral of dx over x squared plus 4, square root of this. Again, since all the terms are positive, plus x squared plus 4, the whole thing goes on the hypotenuse with the square root sign. That is, when I'm looking at this, I don't even see a square root sign. And since x is being squared, that goes on one leg. And since 2 is being squared, that goes on the other leg. And that's u. Now, I like a trig function that gives me, so any trig function is a division of two sides. I like to divide two sides that gives me the simplest thing for x. And in this case, it's the tangent of u. It gives me x over 2. I can even put the over 2 there. And I like this because now I can find dx easily. Take the differential of both sides, 2 secant squared u du, that equals dx. Okay, I have dx, great. Now, what about that? Well, if I do the hypotenuse, not divided by x, no, but divided by 2. The hypotenuse divided by the adjacent. That's the secant of u. That's the square root of x squared plus 4 over 2. The over 2 I'll put up there. Bingo, I have the bottom. Okay, so now it's routine. Just substitute back. Dx, at least the next step is routine. Dx is whatever it is. Square root of x squared plus 4, it's whatever it is. 2 secant u. Okay, well the 2's cancel. 1 secant on the bottom for 1 secant on the top. And now you have the integral of secant of u. Well, the integral of secant of u is ln of the secant of u plus the tangent of u plus c. And the secant of u, well, we have 2 times the secant of u. So this divided by 2 gives you the secant of u. X squared plus 4 over 2 plus the cotangent of u. Well, we have the tangent of u, it's x over 2. So the cotan will be 2 over x. That should be plus tangent u plus tangent u, which is x over 2 plus c. Now, the answer in the back of the book will say that the answer is ln of the square root of x squared plus 4 plus x plus c. And the reason is I can write this where common denominator with a common denominator plus x over 2 plus c, but then I can write it as the ln of the numerator minus ln of the denominator plus c. But that's a constant. And when you add it to that constant, you just get a different constant. You get big C. Big C is just little c minus ln of 2. Okay, so that's how you should write the answer. Let's do a few more. Suppose you have the integral of e to the x times the square root of 1 minus e to the 2x dx. Now, I see a 1 squared here, and I see e to the x squared over here. So I'm going to let u equal e to the x. So du will be e to the x dx. So e to the x times dx, as I said, that's du. And this is going to be 1 minus u squared, because u squared will be e to the x squared, which is e to the 2x. So I get 1 minus u squared du. And possibly trying to look to see if we did a problem that simplified out to the square root of 1 minus u squared. So just to be sure I didn't make a mistake, if this is u, then yep, this times that is du, and this is the square root of 1 minus u squared. Okay. When it comes to 1 minus u squared, the positive term is 1. Actually, it's 1 squared. So the 1 goes on the hypotenuse. Here, we have minus, and it's u squared. So I'll put a u here, and this squared minus this squared goes on the other leg. Now, obviously, I used u already, so maybe I'll use v. And turns out that the sign of v is just u over 1, or u. So that's good, because cosine v dv is du. So now I have du. That's just brilliant. We have that. And the cosine of v is just this over 1, which is just this. It's just the square root of 1 minus u squared. So I have that. So the square root piece is just cosine of v, and du is cosine of v dv. So this is cosine squared v dv. And what we learned from the last section is this is 1 minus cosine of 2v over 2. Just give me one moment. 1 plus. Okay, and this is a pretty standard integral dv. It did say dv. I can pull out the half. So we just need to compute these two integrals. The integral of 1 is v. The integral of cosine of 2v is sine of 2v over 2 plus c. Okay. So what is v and what is sine of 2u? 2v. Okay. Now, I don't know anything at all about sine of 2v. I know everything about triangle v, but not angle 2v. So this here is just 2 sine v cosine v, and the 2's cancel out. Okay, so now I can answer both of those because I have the triangle. And we know that the sine of v is u. Interchanging those two, we get the sine of u is v, except it's inverse. So it's the sine inverse of v plus the sine of v. The sine of v is u, times the cosine of v. Well, that's also right here. 1 minus u squared plus c. Now we go back and we see where u was. U is e to the x. Okay? It is what it is. It's 1/2 the sine inverse of e to the x plus e to the x times the square root of 1 minus e to the x squared, which is 1 minus e to the 2x. And there is that integral. Suppose you have the square root of 1 minus x dx over the square root of x. Now, me personally, I see trig substitution here because x is the square root of x squared over the square root of x dx. So I'll definitely simplify this by letting u equal the square root of x. Now, in terms of getting dx, I can take the differential of both sides right now, but I think it'll be better if I square both sides. So now 2u du is dx. Okay, I have dx, I have the square root of x, and 1 minus x, this is 1 minus x. So if u squared is equal to x, then 1 minus u squared is 1 minus x. Okay. So let us substitute this in. What's underneath the square root sign is 1 minus u squared. What's in the denominator, square root of x, that's u. And dx is 2u du. Well, the 2 I'll pull out in front, and I'll say goodbye to the u. So I have 2 times the integral of 1 minus u squared du. Now this was a test of mine, and I didn't remember any of these integrals. I'd go back to the one that I just did right here. That became this integral. Became 1/2 sine inverse of u, etc. So there's the 2, became 1/2 the sine inverse of u, sine inverse of u plus u times the square root of 1 minus u squared plus c. Well, turns out that that cancels, so you just get the sine inverse of u plus u square root of 1 minus u squared plus c. What will be different here is what u was, but this integral doesn't change. U was the square root of x. So it's the sine inverse of square root of x plus the square root of x times the square root of 1 minus square root of x squared, which is x, plus c. And that is the integral of that. That's the solution to that integral, and this finishes this section on trig substitution.